Hello and welcome back to Lesson 4 Graphical Analysis. In this video we're going to be doing Example 2 and continuing on to Part B. Part B of this question is asking us to find the displacement that this object travels from 9 seconds up to 28 seconds. Alright, so how are we going to find displacement on a velocity time graph? Well, we know displacement has a value of just meters. So if we have the units on our rise of meters per second, and our x has the units seconds, if we multiply these together, these seconds will cancel, and we're going to be left with just the units. So what represents multiplication in a graph like this? Well, if we multiply the x by the y, essentially what we'll be doing is we just take the area underneath the graph of the points that we want. Really what we can do is we can solve for this quite geometrically, because when we have 2 points on a linear line, we can split this off into a rectangle and a triangle. That's what we're going to be doing to solve this problem. Alright, so how do we go about that? Well, first we're going to need to identify the locations of a couple points. Those points I am going to label on my graph, and I'm going to say that this comes across as at about 2.3. So this is going to be 2.3, and this is going to be, what will this be? This will be time of 9 seconds. Right, 9, because that's our first point that's acting, the 9-second point, and 2.3 meters per second. Well, it's actually 230 meters per second. So maybe I'll put that here. 230 meters per second. All right, what else do we have? This point down here, we're going to say this is 28 seconds. And what did I get? I got about 120 meters per second. Great. Okay. Well, if this is 0 down here, right? 0 on the y. Let's solve for the area of these two shapes. I'll do one that way and one this way. Well, we can just use geometric formulas for this. So let's say that the area for these is going to be equal to, let's do the rectangle first, length times width plus, this is going to be length times width, or base times height. I'm going to do, again, length times width of this, but divided by 2 because it's a triangle. All right, if we want to plug some values into here, what do we need? Well, we know that this one is going to have a height of 120 meters per second and a length of, well, 28 minus the 9. So this distance from here to here is going to be 28 minus 9, which works out to 19, I believe. So we're going to say that this length times width, the length is 19. The width, we're going to say, is sort of the height on this one, is 120. Perfect. And we're going to add some value. We know that this width value here, or we call it length, I don't know what we're calling these values right now, but this is going to be, again, 19, because it's the same distance across, except the height is different. Here we have this height of 230, or 23, 2.3, 230, and we're going to subtract the height here of 120 to get this value. So this is going to be 230 minus 120, which is going to give us 110. So this distance here, that's 110 meters per second. So 19 times 110 divided by 2. All right, our numbers are in. All we have to do is plug that into our calculator, and we get the answer. When I plug that into my calculator, I get an area equal to 3.3 times 10 to the 3 meters. And that's my final answer. Put a box around that. And that is the displacement. You see the units, just in meters, what we were hoping for.